Hi and welcome to one of Arm's AI Tech Talks, bringing you the latest in AI trends, technologies and best practices from Arm and our ecosystem. Make sure you subscribe and hit that notification bell so you don't miss any of our upcoming talks. And don't forget to view the playlist too in the link above. I hope you enjoy this Tech Talk.
Welcome everyone today to our virtual Tech Talk. Fast inference on Ethos-U55 with Arm ML Embedded Evaluation Kit. Next slide, please. And today I am very happy to introduce our presenter, Elham Harirpoush. She's on the Arm AI Developer Evangelist team, and her focus is delivering and educating the best-in-class machine learning developer experience with ARM-based technology. Before joining ARM, she worked as a machine learning engineer for nuclear and healthcare industries. Elham, take it away.
Thank you, Carl, and hello, everyone. Before starting the workshop, I want to do a 5 to 10 minutes recap of our last AI Tech Talk for those who were not able to attend the talk. So first, I'm going to talk about what is ARM Ethos-U55 microNPU and ARM virtual hardware. Then I'm going to explain you that how you can optimize and compile a neural network model targeting for Ethos-U55 with TensorFlow model optimization toolkit and Vela Compiler. And finally, I'm going to explain you how we are going to use ML Evaluation Kit and what is ML Evaluation Kit. Ethos-U55 is a ML processor called microNPU that can work with Cortex-M processors, and it allows acceleration of neural networking and embedded devices. It is designed to support most common machine learning operators and workloads, including CNN and RNNs with 8-bit activation or 16-bit activation and 8-bit weights as well. It comes with different configuration of 32, 64, 128, or 256 max per cycle, and it supports TensorFlow Lite micro runtime and works with Corson 300 base FVP or fixed virtual platform. The fixed virtual platform or FVP is a digital twin of development board loaded with Ethos-U55 and Cortex-M55 processor. In fact, it behaves exactly like real silicon, which allows you to run and test software application without development board. And in this workshop, we are going to use Corson 300 reference design. So how to access and run an FVP? You can use an ARM virtual hardware, which is an accurate representation of a physical system on chip and runs as a simple application in a Linux environment for easy application scalability in the cloud. And it removes dependency from the silicon availability and powered by Amazon Web Services. Developers can launch Amazon Machine Image or AMI running as a virtual server in the cloud. You can find the AMI on AWS Marketplace by searching ARM virtual hardware. And it's configured with fixed virtual platform and compiler and other tools that in this workshop we are going to use all of them to build, optimize, and compile and execute a neural network targeting for Ethos-U55. So to deploy your machine learning application and embedded devices with limited memory or computational power, several model optimization can be applied. And to remove those constraints, TensorFlow model optimization toolkit provides optimization techniques such as weight clustering, pruning, and and quantization. And based on the optimization technique, the complexity and the size of the model can be reduced, which result in less memory usage, a smaller storage size, and download size. For example, with weight clustering technique, the storage and the size of the model can be reduced by replacing similar weights in the layer, in a layer with the same value. And in addition to this, running your deep neural network on a resource constrained embedded system using 32-bit representation is not practical due to massive number of max or multiply accumulated operation to be computed for the weighted sum of the neurons input. And optimization is necessary for some accelerator hardware, such as Arm Ethos-U microNPU, as it performs calculation in 8-bit and 16-bit integer. To deploy your neural network on Ethos-U55, you need to compile a trained and quantized model, which we quantize it with TensorFlow optimization toolkit via Vela to generate an optimized model that can perform efficiently on U55. And Vela is an open source and developed by Arm. You can download it from review.mlplatform.org or via pip install. The Vela Compiler, it has top level of functionality. The Vela parser model into a TF-Lite format and checks if the operators can accelerate by Ethos-U55, and for those that the model cannot be accelerated are left unchanged and will be instead running on CPU or Cortex-M CPU using appropriate kernels such as SimSys and kernels. And it allocates memory for all tensor for both microNPU and Cortex-M CPU. And the output is an optimized TF-Lite, which we will see later in the workshop. And also it comes with configurable behavior, which I will explain in the workshop, how to set the different configuration for Vela. And finally, to write your application for Ethos-U55, you can take advantage of Arm Machine Learning Embedded Evaluation Kit, which allows you to quickly build and deploy embedded machine learning application for Cortex-M, M55, and Ethos-U55, sorry. In this workshop, we will see first how to use a trained model and optimize it with TensorFlow model optimization toolkit, following by compiling with Vela, and then configure and compile the build project with ML Evaluation Kit. And finally, deploy the application on Ethos-U55 with Arm virtual hardware. So the workshop instruction, Carl, do you want to navigate through the workshop instruction, or I can?
Sure. Everyone should have received an email with an IP address. It should be from me. Let's see, raise your hand if you did, but check your email address. It should have an IP address that you can connect. You got the email. Did the IP address work in there?
Sorry. If you get the IP address, you should copy the IP address and, two dots and on port 8000, and then navigate to the project, micro speech Ethos-U55, and open the notebook.
Can you go back to the slides?
Yeah.
Anyway, the username is Ubuntu and the password is ARM virtual hardware.
Yeah.
Let me know, and then if anyone's having any problems, send me a message. If you're not seeing or getting any of that, some of the instances I'm still starting the Jupyter Hub on.
Okay. Let me know when everyone is ready.
Yeah. So when everybody's ready, put your hand up. Okay, someone doesn't have an IP. Oh no, okay. There's no IP address in the email. Okay, yeah, something broke. Yeah, I was worried about that. Okay. No IP address, no IP address. Okay. No IP address. Okay. Yeah, that's interesting. One second, please. Sorry about that. Let me try this again. Okay. Something weird happened when I tried to send those emails. And if this doesn't work, I have a plan B, which we'll see. Okay, hang on. Resending the emails right now. Sorry about that, everyone. Please check your inbox. This is going to be to you. Okay, sending that now. You should see another email from that same address. Oh, whoops. It looks like there's a space in the IP address. So you're gonna have to just copy and paste it and do your IP address colon 8000. But you should be receiving those emails soon. And if anyone is having any issues, please ping me in chat, just like you were doing. Give it a minute because that is sending right now. But it should be sent so in the next few minutes. And then put your hand up once you're connected. And then what might happen is when we have most everybody connected, Elham, I'll let you know and you can get going.
Okay, sounds good.
Also, let me know if you are getting the email with the IP address in there, so I don't have to resend them. Great.
Okay.
Great.
Yeah.
Looks like you're getting the email addresses and it's working. If anybody doesn't see the Jupyter Hub kind of sign in, let me know. Some of these I'm still getting running. And then when everyone connects and opens the projects microspeech U55 notebook, still not getting the mail. Okay, it should have gone out. I will start sending out IP addresses to anybody who doesn't have.
Maybe it goes to their spam email because it's a long list.
It's possible. It should be from my address. So carl.feeser@arm.com. You should see it. Double check and search that. And if you still don't see any, you should see two emails at this point. One has an IP address in it and one doesn't. If you don't see either of those, message me. Okay, it looked like it's working now. Cool. Site can't be reached. Okay, great. Yeah, if you're getting a site can't be reached, send me your IP address. Thank you, Chiru. That's perfect. That will help.
So how many people get their IP address?
Okay. Let's give it like another minute or two. Okay. Let's see, 1 second. All right, here you should try to Truro, you should try to retry to connect, and then I'll be working with people to get them up and running.
Yeah, it seems it goes to a spam for some people. Just checking in your spam as well.
And then Samir, give me 1 minute and I'll launch yours. Okay, Samir, try that address again. And then Stanley, I'm about to get yours. Okay, cool. If that's most people, if that's I think that's everybody. Stanley, I'm about to get yours. If anybody else is still having issues, send me a message. If not, I think Elham, you should go ahead and move on.
Okay.
Okay, Kwan, I see your message. I'll help you in a second.
So,
but yeah, Elham, go ahead.
After opening the notebook, please navigate to the model optimization for inference on Ethos-U cell and put your mouse here and click it. And then select cells and run all above. Because we are in this workshop, we are not going to cover the training parts. The notebook already has the training section. You can look into it later. Well, actually, the model is trained on Google speech data set and can recognize 8 different words, which, for example, up, downs, left, right, and a couple of more. And then the model is saved, which will take a couple of minutes, not too much. The model is not very heavy. And then we evaluate the model because, okay, just give it a few seconds. Yeah. It's almost done. So the model will be saved with the accuracy of around 82% on test set, which is a reasonable accuracy. And as you can see, the size of the model is around 90 megabytes. So to optimize our machine learning model for inference on Ethos-U55, we are going to use weight clustering API, which is contributed by Arm tooling to the model optimization toolkit. And here with this cell, if you navigate to it and run it, and you can define a model and apply weight clustering to a pre-trained model. We are defining the number of cluster with 32 here, and the cluster centroid is linear. You can define another technique, for example, randomize, which I think linear makes much more sense and better. And then we are fine-tuned the model with one epoch to get the, with one epoch and evaluate the accuracy against the baseline. It will take a little bit time. So if we are evaluating the model accuracy against the baseline, you can see that the model accuracy didn't change too much, and we still have a good accuracy result after the clustering. So in order to deploy our machine learning onto Ethos-U55 and take advantage of microNPU, we can combine the weight clustering with post-training quantization. Here, sorry, this is for the clustering. I want to show the size of, I should navigate it before this. So, the size of the model with clustering technique decreases. I think it creates 3 times smaller than the actual size, which you can see it here. Here is about 90, and after the clustering, it decreases to 6.5 megabytes. And right now, so to deploy and to use the quantization, here I use post-training quantization to quantize our model. You should first take a sample for calculating the range of values that the tensors can take. And here, to deploy our model for Ethos-U55, as I said, the model should be quantized into int 8 or int 16. And here I use int 8 and for weights, and int 16 for weight, for activations, I mean. So the cluster and quantized model is ready. So if we see if we want to compare the accuracy after the quantization, we should compare it with this function eval model to evaluate it. And you can see that the cluster quantized model and cluster model still have the relatively good same accuracy, but the size of the model decreases significantly, which is very good to deploy for embedded systems. So right now, everything and the optimization, we apply the optimization, and the model is ready and to compile with Ethos-U55. So to compile with Vela Compiler, sorry for that. And basically, all you need to do to compile your model with Vela is to feed your TF light from the here that you created here. You can see it quantized cluster model and cluster model here. It needs a TensorFlow light format, and also you can configure which hardware accelerator that you want to use. For example, here we are targeting for U55 with 128 max. Also we can set the optimization strategy to maximize the performance of the model or minimize the SRAM, which here I use the performance, and the model will be saved as a TF light with quantized with the name of quantized cluster. So Vela actually we parse a model into a TF light format, and Vela check if the operator can be accelerated by the U55. And for those that are not and that cannot be accelerated, it falls back into the CPU. So the Vela output have custom operations with which can be run on Ethos-U55 or on CPU. So you can see the acceleration configuration here, and it prints out some of these, and also it provides you the number of NPU cycles. So up to here, we quantize and then compile our model. And so we want to then deploy our model for Ethos-U55. Here we can use Arm ML Evaluation Kit, which helps you to create, to test and evaluate the performance of Ethos-U55 and Cortex M55. ML Evaluation Kit has three main functionality. You can see the performance, as I said before, the performance evaluation of your application with printing out of the number of NPU cycles and amount of memory transaction. Also, ML Evaluation Kit has a I can say available developed machine learning applications such as image classification, anomaly detection, and many more that you can check in our ML review and .ml platform later. I will add it to the notebook later. Sorry, I forgot to add it here right now. And it's very easy to use for your application. For the develop application, you can just build your build system with build and default.py, which is included in the evaluation kit. And for your custom model, you can test the performance of Ethos-U55 with inference runner capability. Which configure the build system, and so you can configure the build system with first through three steps. First, you specify the Vela configuration and compile the model, which we already did it before, and then we need to configure the build system with CMake and compile the project. Here, we are making a build directory and navigate to the build directory, and then configure the build system with CMake with different parameters. Let me, if I navigate it here, sorry. We define the target platform as MPS3, which could be FVP or FPGA. And the tool change, we are using GCC here. It depends on which tool chain you are going to use. You can use ARM GCC or ARM Clang as well. And you need to define your inference runner TF light pass, which will the output of the which is the output of the Vela is located here. You can see it. A quantized cluster Vela TF light we provided here, and one of the parameters that we can set is inference runner, which the inference runner option, which profile the inference speed for your ML application on Cortex M55, and you can see it later. So we can build it right now. It will take some time. Actually, during it will set up all the necessary things for you. And okay, the configuration is done, and the build is under the ML evaluation kit build directory. So compile the project. Which takes a little bit time. You can navigate to the evaluation kit, build, and bin. It's not ready yet, but after it's done, we can see the result of build, which are placed under here. Does anyone have question or? So you can see that the number of NPU cycles, SRAM, okay, little bit more time. All of this notebook is running on ARM virtual hardware and with FVP, with configured FVP and compiler and other tools that we need for running this example. So I think the build is, yes, it's ready. So you can see the result here in bin, and you can see the Ethos inference runner AX F file. So to run your application with FVP, all you need is to define your a specific hardware target. Here we are using U55. Actually, U65 is also available under Corson 300 FVP. And the thing that you should pay attention here is to make sure that the number of max per unit for Ethos-U should be the same as what we define in Vela. In Vela, we define it 128, but in here, we need to define it the same. And these are setting our FVP to print the result on the terminal up to here, and then we just need to provide the path of the inference runner binary file, which if we run this cell, so it prints out some of the information for you. For example, the number of operators in the TF-Lite file after Vela, which is here is 3. We have quantized Ethos-U and dequantized. Ethos-U will run our the operators that are under Ethos-U will run on microNPU, and the rest will fall back onto CPU. And you can also check the number of check the number of memory transaction across different buses here. And yeah, that's the result. You can see that the model is performing very well on Arm Ethos-U55. Were you able to run through the notebook? Does anyone have any question regarding each section or running an issue? Yeah.
Let's see, George, I'm going to answer George has a question. I'll answer it. He asked, is this Jupyter notebook available outside this workshop? I'd like to work with this later after setting up AVH locally. AVH locally, you can set up a few things, but you're going to have to get the eval kit set up. You can also use the ARM virtual hardware, which is a free AMI on AWS. And right now the notebook's not available, but we'll put it up probably in a few weeks. But for right now, you can just download it from the Jupyter Hub instance, which is pretty easy. Han asks, is there a max number of operators that can offload to Ethos as one subgraph? Do you know that answer? Does anybody else on the call know that answer?
Go ahead, George.
So the Vela Compiler supports basically a subset of the operators that are can be executed by TensorFlow right from microcontroller's inference engine. And basically, if your model is using those operators, it's going to be those operators are going to be run on the NPU. And if you're having a TensorFlow right from microcontroller operator that is not supported by Ethos-U, then this operator is going to be run on the Cortex-M part of the system.
Yeah, but is there a max number? It's basically just dependent on the memory, right?
Sorry, what do you mean under max number? Or maybe Isabel can comment as well. Isabel?
No, there's no maximum number that we know.
Yeah.
Yeah, it will depend on how big is the model and if it fits in the memory. Yes.
Yeah. So that, I mean, there's no there's a max number, but there's not like there's no theoretical max number, but you're limited by the size, the configuration of the hardware, and
yep, exactly.
Yeah. But yeah, there's only certain operators that will run on the Ethos. Cool. Samir asks, is there a way to compile the PyTorch models directly without converting the Torch model using Onyx to TensorFlow models? To my knowledge, no. Does anybody else have a? There is a way to do it using Onyx. But does anybody else know? I don't think right now we have a direct PyTorch route to U55.
There's no direct support for PyTorch. You need to go on an X TensorFlow, right?
Right. Hopefully that'll change soon. Yeah, at least for now. We get that question a lot, so we're looking at it.
Or another way, basically, you need to find a way to convert your model, your PyTorch model, to TensorFlow. One of the common ways is Stronix, but there's also some other open source frameworks that allow you to do that. So basically, you need your model in TensorFlow wide format.
Yeah. So basically, that is the answer. For now, there's no direct support. This is the best way for you to do it right now. It's on our roadmap to have increased the tooling for PyTorch, but now there is nothing direct from PyTorch. So the methods already mentioned are probably your best bet to convert it to TensorFlow.
Han asks, can you briefly explain the memory model used by Ethos, e.g. does Ethos need to copy all of the weights tensor to local memory? That is true, correct? Panelists? Because it's really hard to run a model without the weights.
Yes, that is correct. The system is having, there's a couple of different memory modes that are supported, and by default we're using a memory mode in which the SRAM is shared between the Cortex M55 and Ethos-U55. And the microNPU is also having its own internal buffers, where obviously the weights and the activations need to be placed so that they can be essentially taken into account for the computation. Isabel, would you have something to add, or Mohammed?
That's okay. Let's say that the Ethos-U operators, when you pass through Vela, it just shuffle correctly for the hardware, the weights and the tensors and whatever is needed. So yeah, and anyway, everything has to be copied in memory, of course.
Any other questions? Samir asks, is there any plans to support graph neural networks? That's a good question. I don't know that one. Does anybody else on the call know that?
To my knowledge, that's still a very niche, like research, type of model. So I don't think there will be immediate efforts for that.
Yeah, I mean, graph neural networks are the new hotness, so we'll see. But yeah, right now I haven't heard of any plans at the moment. Han asks, does Vela support any weight compression? Vela does weight compressions, right? It's not all in TensorFlow model optimization toolkit.
Yes, so Carl, this is correct. Basically, Vela, so the Ethos-U55 hardware processes the model weights via a hardware weight decoder, and Vela arranges those model weights into blocks of weights, and then feeds those weights into the hardware weight decoder of the NPU.
George. Han, again, any rough idea how much extra space does the command stream take for a typical model? That's a good question. I don't know that one. It's probably not much. Does anyone know? Do you have like how much extra overhead is required beyond the model to run networks on U55? It's probably not a lot.
So the size of the model is actually not necessarily going to increase because Vela is basically taking the model and is rearranging the weights and essentially into a weight that is ideally going to result into a model that can be even smaller in size. So it's in some instances, the optimized model is going to be slightly smaller in size. In other instances, it's going to be slightly larger in size. Isabella, would you like to also, do you have anything else to say on that one?
No, that's correct. Usually Vela model is smaller than the vanilla model, and the code size itself from Eval Kit is not huge, it's a few hundred kilobytes, I think.
Any other questions for anybody? Like, we've got a great panelists today too, or for Elham, or questions on the notebook itself. Feel free to download it. We will be hosting it at some point. We just haven't done that yet. But yeah, any other questions for anybody? If there are no more questions, I will leave these instances running for like the next half hour and then shut them off. But feel free to try the ARM virtual hardware on AWS. That's probably the easiest way to get started with it. You can also take a look at the eval kit directly on mlplatform.org. We'll be sharing these slides. Thank you, Elham, for presenting and working on this notebook so much. Thank you, our panelists, Isabella, George. Who else is on? Mohammed, thank you. I couldn't pull up all the participants fast enough.
Thank you.
Yeah, thanks and then thank everyone for coming and we're running through this with us real quick. That'll be it. If there aren't any more questions, yeah, have a good one, everyone. Thank you so much.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.